You know how fun this sport? My wife started laughing at me. It's like I saw sports like no way down.
Yeah, at least we filled out this time.
Yeah. I've been perfect though. No, it's nice to knock that in there.
They said, like, this thing trying to score.
Just roll right by like 5 feet. It looks good up there. So.
Because you know he's gonna keep trying.
Yeah. That was our first time throwing it out.
I think you're
Oh, man. Well, after that, we
Yeah, Saturday night. Saturday. What? Like 16 seconds. 3 seconds. I think they're right this game for it. Sucks not getting a point out.
I friend that anyway, says with the Rangers. She's just like, wants to be a fan of hockey. I don't know if she ever how much she loves it.
What is funny, you know, I put on
She's like, I learned to be
I'm not a team of Raiders.
yes. Right now, I'm like, there's all these like values that I'm trying to do, whether or not they're like big C or incredible or they're big. Yeah, it is. So I'm kind of happy. The thing about these assignments is that like, you're really wrong.
All right, you guys ready? How's the project coming? You gonna have it done for Thursday?
Friday? Let's do Friday.
Friday, the 19th, right?
Yes.
So I'm not changing the date. Yes. So whatever that date is. Is it Friday?
Yeah.
Okay, it's that date. So let's do it midnight, I think, right? That's what it's due. Okay, so all right, so we'll endeavor to get those graded and back to you. I will do it next week. So that's good work. Bruce and I will read that and have some comments for you. And you'll have a chance to revise it later if you want. So you're gonna get a grade on it. And then if you guys want to redo it and get a different grade. So you can also use that for the comments we provide for the presentation too. The presentation should be the same as the paper based presentation of new stuff and new stuff. Okay, yeah.
Are there slides you do at the same time as papers?
Yeah, the slides we do the presentation.
Okay.
I mean, technically, when I put the slides in, put on the agenda, that's fine too. I was determined on the day of the presentation. Yeah.
Is there like a peer review form we have to do?
That's the peer review of it.
Sometimes it would be like us.
Oh, reviewing your other group members. You do review your other group members. So yeah, there will be a form for that. I will have that up there. Like a problem, so that I'll put that up later. Yeah. It confused me because last year when we weren't together in class, I actually had to peer review the actual presentations because we didn't be together. But since you'll be here, watching the presentations and you'll be able to ask questions of your peers giving their presentations. That's adequate peer review, right? So we're not going to do that. Harm peer review. But yeah, you'll have a chance to review your work. Okay, so if there's any questions on that this week, as you get ready for turn that in, send me questions, okay? But yeah, Bruce and I will try to get that back to you. Well, for sure, right after Thanksgiving weekend. Before. Okay? That sound good? All right. Any other announcements? Probably. Okay, this is exciting. Climate change. Let's talk a little more about that. Yay, whatever. Okay, I just put this back up because I want you to remember this picture. I just remember this. Everyone got that picture seared in one end? Okay, just remember it. Okay. So it's like we're filling out the atmosphere with carbon. Some people use, if you've taken the climate change class that I think Brian Marks teaches in geography, they use the bathtub example, like filling a bathtub. That's another good analogy, right? But here we're kind of filling a big tub up with carbon, and it's a non-renewable resource, basically, the atmosphere, right? So, okay, so just keep that in your mind. Social cost of carbon is defined. We got to that and talked about that. It's present value, the future stream of damages caused by 1 ton of carbon emissions a day. So you think of that ton we're emitting now as we sit here in the room, right? Or we emitted as we drove our cars or ate some food today, whatever we did, that ton that went up in the atmosphere goes up there and it causes damages for a long time into the future. And we actually are, we pretend that we can calculate the damages caused in the future. Those damages are quantified in dollar terms. So that's the effect of climate change on agricultural production, ecosystem services, such as cutting trees or biodiversity. It also impacts on sea level rise, right? So sea level rise could cause huge impacts on human civilizations living close to oceans. And you know, we live here in Ohio right now, at least some of us. All of us live here all the time. Some of us live here some of the time. You know, most people don't live like us. Most people live in normal places. They live on the oceans, right? Fact was, it's something like 80% of the Earth's inhabitants live within 20 miles or something of the ocean. So an enormous number of people live there, and that sea level rise could cause a large amount of damage there. So anyways, those quantified estimates of the impacts of climate change on future populations as it affects all those sort of services within the Earth. They're quantified, and that's then the stream of the effects of 1 ton of carbon on those future civilizations. The present value of that stream is calculated. That's the value of the ton, right? So for the value, that's the social cost of carbon. Does that make sense? Sort of. All right. And this sort of social cost of carbon can be sort of looked at as a proportion of global output. So we can actually then take any ton of carbon that's the social cost of carbon is say $40 a ton multiplied by all the tons that we release, and calculate the damages, right? In total, an aggregate number, which is in billions or trillions, right? And we can look at it as we increase the mean temperature of the Earth from sort of where we are today is sort of right here, right? We're about 1.3 degrees, I think is the latest estimate of the amount of warming we've experienced so far. And scenarios predict that warming could go all the way up to say 6 degrees, and at 6 degrees, you know, they estimate that those damages could subtract about 10% of output. So, you know, what is that? 10% of output. So if you were to actually do what? Somehow cause people all to move away from the ocean because oceans are rising, and they have to spend an inordinate amount of money to what? Fending off the rising ocean, by either building bigger walls to keep the sea out, or by tearing down the existing house and building a new house a little further back. right? That's expensive, that costs money, so that's what those sort of numbers are, right? So the social cost of carbon is not just some theoretical number, it's an actual estimate of money that we'd be spending to try to fend off some of those impacts, right? Make sense? Yeah, sort of, okay, whatever. Okay, so again, over time, as we look at the carbon dioxide in the atmosphere, and temperature is really proportional to this. So this is sort of where we are today in 2021 is about 1.3 degrees, 415 parts per million. That's kind of where we are today in terms of our amount of carbon in the atmosphere. As we go up to 515 parts per million, we get up to 2 to 3 degrees of temperature change, et cetera, et cetera. As we do that, that sort of happens over time, right? And that social cost of carbon keeps getting bigger and bigger and bigger over time. Why is that? Because each time, once it goes up there, it stays there for a long time. And those future damages are even bigger, right? So from the perspective of someone sitting in 2030 or 2040, those really big temperature increases are actually a lot closer, right? So think about it, the discounted value of these really big damages, which are up here a long way in the future, if you're a little further out in time, they actually are bigger. Right? That make sense? Okay, so this tells us something about what we would want to do, that if we want to get down here along this, if we think of the social cost of carbon, these really high sort of carbon profiles, or along this pathway is kind of this business as usual one where we're not doing anything. It leads to these bigger damages. And it also tells us that if we wanted, what the value of getting down to a lower level of damages would be, right? So if we actually spent $145 per ton to avoid $145 per ton, we would actually be down at this lower level, right? So if, remember, this thing is the social cost of carbon, it's the damage. It's basically telling us to tax the amount of money we should spend to avoid those damages. And if we avoided those damages, we'd be down here somewhere, right? So that's the idea of the social cost of carbon, is it gives us a rule that we can use for policy making. It says that this is exactly what the Biden administration is doing, exactly what the Trump administration actually did as well. And we'll talk about how they did that, but also what the Obama administration did. They were the first ones who came up with the idea of saying, we're going to try to set regulations at a rate that's consistent with an estimate of the social cost of carbon. And the Biden administration now has re-estimated the social cost of carbon at $51 a ton. So they basically are trying to set federal policy such that they'll achieve all the policies that cost less than $51 a ton. Okay, so that means that they're going to look at pushing automobile manufacturers to go as quickly as possible towards electric vehicles, up to the point where the cost of that is $51 a ton. That's CAFE standards, corporate auto fuel efficiency standards, right? They'll push renewable energy standards up to the point where the cost of implementing X% renewable energy costs $51 a ton, right? So it'll set the percentage at the point where the cost of that policy is $51. That makes sense? Right, so that's what the social cost of carbon is used for practically, is just as a tool for policy making, so that we can then decide sort of how to set those policies. Okay. Yay! What affects the social cost? What affects social cost of carbon? Well, that's a question for you. I've spoken too much already. What affects it? Yeah.
Technology,
Technology. How so?
for instance, if you were looking at the social cost of carbon technology, I thought of, like, for instance, some type of public transportation we have.
Okay.
And whether it's a bus or a train, will have different effect on carbon they produce, which therefore would influence a different number of carbon, which can influence policymakers' decision to take a train over a bus.
Okay, so technology is interesting in terms of the social cost of carbon. It may affect the social cost. So one thing, yeah, technology is interesting. So the social cost of carbon. So the technology you're talking about are technologies that are cheap, sort of alternatives, right? Cheap mitigation options for reducing the effects of climate change, right? Those are actually more on the cost side rather than the social cost of carbon, which is the clearing side. However, to the extent society can actually achieve, and this is actually happening. So one thing we've noticed in this class is that the cost of solar power and wind power have gone down dramatically, far faster than most people expected that they would go down a decade ago, right? That is, the cost of those technologies have gone down because the technologies have improved, right? Technology change has been so dramatic. And that actually has helped reduce the social cost of carbon, because now we actually expect the future business as usual to be less carbon in the atmosphere, right? So that's kind of a different way of thinking about it. It is because we've been sort of blessed with this fantastic technological innovation that has made all these green technologies cheaper, quicker. We actually are likely to have less carbon in the atmosphere. That does drive down the social cost of carbon. So I'm not sure that's exactly what you're saying. Is that what you're saying?
We got there.
Yeah, that's right. So it could drive, it's driven down the social cost of estimates of what.
Yep.
So,
Does the social cost of carbon estimate differ by location in our country, or is it a global standard?
It could be both. Now, there's a legitimate argument about that. So, what is it about carbon dioxide that makes it sort of the perfect public good or common property resource problem?
The atmosphere doesn't like have territory boundaries, it's just kind of our atmosphere.
Yeah, we kind of have one atmosphere, so it's not like, so sulfur dioxide is different. So sulfur dioxide goes up in the atmosphere and literally comes down as acid rain in a particular location. So it causes damages to specific people, right, in a specific place. And emissions from driving our cars, which cause bad air, that's actually one of the worst, smog, things like that. That's actually really localized, right? It's really bad in California because of inversions, because of where the mountains are and the high amount of traffic they have here. It's less bad in other places. So there are sort of pollutants that are really specific to particular locations. Carbon dioxide just goes up in the air and it mixes almost perfectly around the world. So 1 ton emitted in any location has the same impact on people as 1 ton emitted in a different location. So there's really no regional. Now, that said, there are regional differences in the damages of climate change, right? So some regions are really going to take it on the chin. Coastlines are one that really get harmed badly compared to other places because they're on the coast, right? So it doesn't mean every place gets the same damage from climate change. It does mean each ton, a ton I emit has the same effect as a ton someone that's in Latin America. That makes sense? So that means that there's really just one social cost of carbon. Okay. On the other hand, to the extent that some people have argued that the extent the social cost of carbon is, or that it reflects damages, you should make it very specific for the damages in that particular location. And it is true that damages are different in different places. So I'm only bringing this up because this is actually what the Trump administration used to actually lower the social cost of carbon. So the Obama administration came in, estimated social cost of carbon at $36 a ton, the global estimate. And in theory, our tons cause damages in any other country, and we should be responsible for those. The Trump administration came in and said, well, actually, we don't have any laws that tell us we have to be responsible for people in Africa or Latin America or Southeast Asia, or no tax on a bunch of islands in the South Pacific or something like that, right? And they just said, we're just not going to accept those as damages. So they actually took all those damages out of calculation, calculated the U.S. specific social cost of carbon, which is like $8 a ton. So now, the Biden administration has gone back to the way the Obama administration has done it. The reality is both of those can be economically justified. Okay? There's no completely right answer on that. It's kind of like the world is. Does that make sense? So your answer, it is, my personal view is it's a global thing. So simply because the thing mixes all over the place, that's not personal view. So, what was your original question?
I asked if it's a global standard or is it our
Yeah. Yes, yes. That your answer? Sort of. Okay, I feel so inadequate sometimes. I really do.
We all.
Yeah. Okay, what else? Anybody? Yeah,
Are there social costs for other pollutants?
there should be, there could be. Yeah, there are. So social cost of carbon is just a good a name for a marginal damage. And the other, it is just the marginal damage of a ton of carbon, actually. So the same concept applies in other areas as well. Yeah. It's maybe less complicated in other areas because it's a stock pollutant and you're discounting tons hundreds of years into the future, damages hundreds of years in the future. That's a little more complicated for carbon, but other pollutants like sulfur dioxide clear out of the atmosphere within a couple of years, so you don't have to do this discounting thing. What else?
The kind of like socioeconomic projections, like population or income, they can change and that's what how the social process.
Yeah, it's interesting. So social cost of carbon, it does actually depend on income a lot. So as income goes up, actually, social cost of carbon actually goes up as well, right? Yeah, the reason for that is because in the social cost of carbon calculation, higher income people are basically worth more. I'm not making a value judgment on that, just the way the calculation works. Because wealthy people have higher valuation of the damages of climate change than not so wealthy people. That's not to say that the impacts aren't more important on, or as important on less wealthy people. That's just to say in that calculation, that's how it works. Right. It's one of the things about economics, is usually more people with more income are valued more in the calculations. Yep.
I know you gave us like a lot of the variables that go into determining the social cost of carbon, but are there any that are like weighted way more heavily than others? Like, do we weight like effects to human health more than we do like potential sea level rise effects?
Yeah, so there are some that are just bigger. It's not that we necessarily weight it more, it's that they're bigger. So human health effects are bigger, actually, because we do value those significantly. Right, and the extent that climate change is predicted to cause additional death, heating deaths and things like that, those are valued very highly, right? Because actually, the current value of statistical life that we use in the U.S. is used as the basis of the social cost of carbon, and this is applied to everybody in the world, not just people in the U.S. Just the estimates have largely been made on U.S. populations and European populations, so those are the populations we have estimates for the value of statistical. It's something like $7.2 million alike, and that's applied to people on islands in the South Pacific who are exposed to higher death rates as a result of climate change, right? So that's a significant impact. So just by virtue of the size of that effect, it's not that we're trying to weight it more. It is weighted more because it's a big impact. Premature death from climate change, right? Now, sea level rise is connected to that because a lot of the premature death is due to sea level rise, coastal flooding, and things like that, which actually causes a lot of death, right? Mortality, morbidity. So it's not that we're specifically trying to weight it more; it's just that it works out that it's weighted heavily because that's one of the bigger impacts.
Yeah, that makes sense.
What else? Oh, I got some more things. So you guys got a lot of them. So natural processes could affect CO2 temperature. So here's one you may not have thought about: carbon fertilization. Anyone thought about that? What's that? Did you know if we put all that extra carbon up in the atmosphere, we made trees grow more? You know that? They grow actually faster now than they used to, to bigger size. Forests today are roughly 40% bigger. Trees and forests are roughly 40% bigger today than they were like 50 years ago because of carbon dioxide fertilization. Same thing with crops, you know, it's not that crop, you know, so corn, ears of corn are actually bigger today, partly because we fertilize it with nitrogen. But it's not that we're so smart with the nitrogen, we've also got free fertilizer from the atmosphere called carbon dioxide. That's helped those grow as well. So same thing for all our other crops, wheat, soybean, etc. So that actually has the opposite effect. So the more carbon we get in the atmosphere, there's actually a slowing effect.
When you say trees are bigger, are you referring to that they are able to grow faster?
Cool, they're able to grow faster, they're just bigger. So any
Like the
tree,
individual tree on
Yeah.
average is now, but like.
yeah,
these have
50-year-old
older
tree today
forms
versus
that
50-year-old
are-
tree
okay.
50 years ago, 50-year-old tree today is bigger than a 50-year-old tree. It's the exact same type, exact same site 50 years ago. Yeah. Just because of more carbon in the atmosphere. Yeah. It's fertilizer, yeah. And physically, it's hard for us to see it, but you just have to think about a volumetric relationship, right? That it doesn't take a lot of extra growth on a tree to make it substantially bigger. It doesn't, you can't actually see it, right? It's just, you guys know what volume is, don't you? You guys have all seen that before. Volume, right? I mean, just a little bit of extra. I mean, just add a little bit all around that thing, all along that thing. Doesn't take much extra stuff to make it actually substantially bigger because it's a volume. Okay, whatever. So that's that. Economic growth, population growth, that's your income point right there. Carbon intensity of the economy, that's technology change. Mitigation efforts, so anything to do to try to avoid climate change that could lower the social cost of carbon. Adaptation efforts, those actually lower the social cost of carbon. That's kind of an interesting thing. That if we actually take a lot of effort to try to avoid climate change, it means we lower the social cost of carbon. We should also do less to mitigate climate change. It's fascinating one. And the most important one is assumptions about the interest rate, right? So there's what we use for the interest rate or discount rate has a huge effect. We'll talk about that real quickly. We'll come back to that in a second. So the discount rate has a huge effect on the social cost of carbon. If you use a 5% discount rate, the same damages lead to much lower social cost of carbon. So rather than sort of $46 to $50 per ton, the social cost of carbon at a discount rate of 5%, $13 a ton. So the federal government in the U.S. has chosen to use 3% discount rate. I think the Obama administration is considering using a 2.5% discount rate as well. So that would further make the numbers bigger, right? The reason is why? Because the social cost of carbon, remember the definition of it is the present value of future damages. If you use a lower discount rate, you weight the future more, right? Did I tell you guys to just remember that, steer that into your brains early on? Use a lower discount rate to weight the future more. If you weight the future more, that means you're gonna have a bigger social cost of carbon. That means you're gonna do more to avoid climate change, right? Yay, make sense? So, you know, where we argue about this thing is that because unlike private markets, this discount rate that we use for the social cost of carbon, it's a government decision, right? So if it was private markets making this decision, private markets would choose a discount rate like 5%. They would choose a higher discount rate, right? Because that's the rate that they have to pay their lenders. So if the private market goes out and borrows money, invests in capital, they have to pay 5, 10, 15% for that to borrow that money, right? So they're going to use higher rates, but the government doesn't have it. The government actually is a choice and it isn't the private markets. It's basically a government thing, right? You're borrowing money in different ways than the private market is, and they borrow at much lower rates. So the government can use lower discount rates in government decision making. All right, and that's why this becomes such a big issue, at least the discount rate does. You know, because it's ultimately It's not decided by markets, it's decided by a couple people, right? What was it? Yeah. Now it's political, but it's no fun. So back to the damages, this is just a couple slides pointing out that we can actually estimate this stuff. This is not rocket science. This is just basic, simple stuff. So this is one of the best examples of one of those, one of the best studies in economics of the impacts of climate change. And the point is that today we have so agriculture is interesting. How long has agriculture been around? When was the first agricultural revolution? Anyone remember that one? Back when we were very young. Started out 10,000 years ago, right? When we basically domesticated animals for the first time, started to grow meat, things like that. Yeah, it was literally 10,000 years ago, right? The first agricultural revolution. Right, so we've been doing agriculture for a long time as humans. And agriculture has always done what? Agriculture has always followed the climate. Right? So we've always adapted our agricultural production techniques and technologies to the existing climate, whatever climate we had over that 10,000 years, right? It's changed a lot over 10,000 years. So agriculture is already climate adapted, right? So the agriculture we have in the US, of course, we've only been doing agriculture in the US for at least the way we do it in modern ways, for 200 years or so, right? And so in the US, we've done the agriculture in sort of the modern techniques using the machines, heavy use of machines, and more recently, heavy use of chemical fertilizers, et cetera, we've done a good job of adapting that agriculture to the existing climate, right? So it's a pretty simple thing to actually then show that net returns, that is the economic return in agricultural land, is directly related to temperature and precipitation, and it actually is, right? It's one of the easiest statistical relationships you can show. So we have in the US really good data collected by the Census Bureau on the net returns to farms from the 1930s to the present. Okay, you can actually use that data to show statistically exactly how farms net returns, that is their economic return, is a function of temperature precipitation. And then use that to show how those net returns, and that's what this picture shows, how those net returns will change when temperature and precipitation change, right? So yeah, it's a little bit of a projection, but it's based on data, based on statistics that is not really all that complicated. And this is not something you can do just in the US, you can do this in any part of the world that people have. And so it's pretty easy to show how agriculture will be affected by climate change. And as you might expect, it's not all negative. There's places where climate change causes really large negative effects, and there's places where climate change causes large positive effects, right? What they found with agriculture is that basically a hill-shaped function, and that the optimum is somewhere around an average temperatures of 11 degrees centigrade, based on global estimates of the net returns to agriculture. This is net returns. So it's like dollars per acre, per hectare, right? Where is 11 degrees? Anyone know where 11 degrees is? Centigrade is the average temperature. Do you guys know how lucky you are? You don't know how lucky you are. You live in Ohio. Ohio's average temperature is like 11 degrees centigrade. Do you know that? Pretty amazing. So, kind of we're right here at the top of the hill. Okay. So it turns out that if you're sort of down here and it's colder, you're 10 degrees, which is, you're up in here, you're probably going to get some benefits from climate change. If you're over here, you're going to get some harm from climate change. Okay, so that's one of the outcomes of sort of all the agricultural studies, is that there are people who are going to benefit and be harmed by climate change, and that's very much a function of average temperature. All right. So, yeah.
Are those numbers from 1994?
Yeah, and you can't really take these numbers and use them today. You have to update them a lot. But there are more updated studies just like this that have been done more recently. I just don't have it mapped out as nicely as this one is.
So that figure is not, if I'm reading the title and everything right, it's not trying to predict how future climatic changes will impact it. It's just literally saying, here is the climate in 1982, and here is basically like the impact of the temperature and precipitation on crop weights, like just taking those two factors out of the entire equation of what impacts crop weights.
Yeah, I guess you're right. This was the average. I thought I put the one that showed the change as a result of the 2-degree temperature change. So they also have a picture which is the effect of the 2-degree temperature change, which looks like this and actually just moves the green up and out this direction a little bit. But this is actually just the average value per acre. These are net differences from the average. So the way they did that is they looked at the average, and so this negative, these just say that these counties are all far less valued than the average acre in the US, all right? So this is actually isn't the impact of climate change on those acres. Now, however, this picture, I'll bring it to you next time, should be next time. They do have one that looks at a 2-degree temperature change in Fahrenheit terms, which is about where we are today. And it looks almost exactly like this, but it just moves everything to the north.
We'll be fine. You can just put more energy in Texas and the South. like
Well,
you
I mean,
do, and-
That's one of the issues, at least with agriculture, is in the US will probably be fine with agriculture. That's not true for everywhere in the world, but it's true in the US. At least for now, right? At some point, if we get to 12, 13, we get 3 to 4 degrees centigrade increase in temperature, the US isn't so well, right? And Canada is pretty well. Yeah. You can do the same thing for different kinds of outputs. This is one for forestry outputs. This is recent estimates from the IPCC where they looked at droughts and whether droughts would become more problematic. And not surprisingly, they found that in existing dry places, and all these are existing dry places for the most part, that they are susceptible to, and there's already evidence that they become more droughty. And the evidence is that those increases in droughts. So this is not only showing that there's an increase in droughts, right? But the dots are showing the sort of certainty level with respect to whether they've been able to attribute that to climate change or not, right? So lots of single dots suggesting low certainty in terms of attribution, but some places where they've got double dots where there are more studies suggesting that they have sort of a medium level of certainty that climate change might be a driving factor causing that increase in droughts, right? So there's increasing evidence. The point of this is just that measuring the impacts of climate change actually isn't that, I mean, it's complicated, but it's doable, right? So getting to a realistic measure of the social cost of carbon actually isn't so, it's not such a crazy concept. Why am I doing that? Why do I care? Well, yeah, because Bruce might come in here and say it's a crazy concept. Oh, I know Bruce is going to do that. This is the best part. So I'm going to tell you it's not such a crazy concept. Why is that? Well, because I do that for a living. He doesn't. That's great. You guys are no fun. You used to be fun. God, you used to be laugh. Now you're not funny. Yeah.
Why would you think that it's not like a crazy concept?
What was that?
Why would you think that it's a crazy concept?
I don't know. I mean, most of this stuff is measurable, right? Most of these impacts we can actually try to figure out and measure them, and they're not perfect. I mean, this is actually interesting because they're actually pointing out that there's, I mean, the single dot is a low confidence in the human attribution level, right? Low confidence means that there's very little, few studies have shown, not lots of studies have shown, but few studies have shown that there's a human signature on that. And in most places, we don't have a lot of confidence, right? So that suggests that actually the science there is not well developed, or maybe it's well developed, but they just have shown lots of stuff on this side and lots of stuff on that side, right? Neither of those actually. But it's suggesting that the science that we can do the science, which is a good thing. I have a lot more confidence in the agricultural impact ones because the data in agriculture is amazing. We've been collecting data for a long time and making the link to temperature precipitation because it actually is exogenous to the agricultural activities. We can identify the effect, so it's actually doable, right? We don't have that same level of certainty in every sector.
Do you have more data like this before, like the agricultural sector?
So there's tons of data, yeah. The ag sector. I don't have it here in this presentation. I don't want to bore you. I mean, you guys just seem so bored as it is. Yeah, there's a lot of data. It's really good, actually. And the ag sector is fantastically well studied. Yeah, because it's always been affected by climate. Okay, so CO2 is different from other pollutants because it's a stock pollutant. So remember, it's that filling up that bathtub, filling up the atmosphere. These other ones, so we already talked a little bit about those, sulfur dioxide, nitrogen oxide, volatile organic compounds are flow pollutants. So again, this just goes to why it's so much more complicated to deal with carbon dioxide than it is with these other things. And this is always a difficult thing in the climate problem, which is that, when we went out and decided as a society we wanted to get rid of sulfur dioxide, we got rid of it, right, in the US. So basically between 1990 and 2010, and I don't think Bruce showed this, he might show the numbers, but he used to show the numbers. We literally cut sulfur dioxide in the US from really high numbers to practically nothing. And the impact on air quality, human lives is immediate, right? It was immediate. People saw the difference. And it's not that way with carbon, right? Because it's a stock pollutant. We can do the same thing with carbon dioxide today, but yet all these impacts that we're having right now, right? Where's the drought? There's these droughts in the western US, right? All these rainstorm events, the hurricanes that are happening today. That's not going to stop, right? That stuff is still there because the carbon's up there, and you can't just get rid of it. So it's just important to reflect on the fact that these flow pollutants is what makes them easier to deal with, is because it's like instant gratification, right? When we actually do a policy to fix them, we fix them, and people notice a difference right away, right? Whereas with climate change, we can stop the carbon, but we're not going to notice a difference, right? But that's just a different issue, right? We do know that these other things, by fixing them, we've really done a good job. The benefits have far outweighed the costs. So just a point on that, but there's just, it's pretty amazing. We're done with those other things. We know, again, that we face the same kinds of cost and benefit relationships with carbon. But again, we're not going to have the immediacy of, oh, we got the carbon out of the atmosphere, so now we don't have any droughts anymore. Actually, we're still going to have droughts, right? We're still going to have hurricanes. They're still going to be more volatile today than they were before because of climate change, right? Or because of the sea level rise we've already got. But the big issue with hurricanes isn't actually, there's not a lot of evidence that hurricanes are stronger today. But the concern with hurricanes isn't the strength of them, it's that sea level has risen. And so that they have a bigger impact on more people, right? So some of this is we've caused the problem to ourselves, right? That we've all of a sudden put more people living on the coastlines. We've added a little bit of sea level rise. And so now those same types of hurricanes we used to have 50, 60 years ago happen, and it just caused more damage. There's more people are there, there's more shit, more stuff to be damaged, right? So anyways, whatever. Okay, so methane nitrous oxides. However, okay, this is a good thing. Yay. Just so people have a little bit of understanding of this, because you might hear these around. So we deal with these things called global warming potentials. Have anyone ever heard of those? Global warming potentials? GWPs? So GWP 100 refers to the warming potential over 100 years of a given gas relative to carbon dioxide over the same 100 years. All right. You could do a global warming potential over 20 years, over 50 years, over 100 years, or over 500 years. It just so happens that the international standard that's most frequently used is to do it over 100 years. I don't know why they picked 100. But that's what the atmospheric scientists predicted, not me or you. Okay, so methane is a gas that also causes warming of the atmosphere, right? The same way carbon dioxide does. It's released through natural gas production. Obviously, natural gas is methane, right? When we produce methane for uses in heating and electricity, we also, a little bit of it gets released to the atmosphere. If anyone, I mean, I was amazed. We took a train trip across the U.S. in the middle of winter, 5 or 6 years ago, crossing North Dakota. It's amazing, because most of North Dakota, thankfully, they put that at night on the train. But you just look out, and that's where the Bakken is, right, where they're producing all this natural gas and oil. And they're not collecting most of the natural gas, right? They're just collecting the oil. And they're flaring off all the natural gas. So they're converting the methane to carbon dioxide, right? In order to, because methane has a really high global warming potential. Each ton of methane causes more warming in the atmosphere than carbon dioxide. So there's a huge amount of this sort of flaring of natural gas, that is burning of the natural gas and just releasing the carbon dioxide into the atmosphere in order to reduce the climate effect. Okay, so methane also is produced by ruminants and rice paddies. It's a big reason why agriculture is one of the biggest emitting sectors in the world, right? It's because of methane production from cows and rice paddies. The global warming potential is 28. That actually should be 36, sorry, 28 to 36. There's different models people use, so there's some uncertainty about what the global warming potentials are. Nitrous oxide is released from energy production and fertilizing crops. So when you put chemical fertilizers on corn crops or wheat crops or rice crops, you release some nitrous oxide that has a much bigger global warming potential of 265 to 298. So 1 ton of nitrous oxide in the atmosphere, I should say 1 ton of nitrous oxide in the atmosphere is equivalent to around 265 to 298 tons of carbon dioxide, right? It's much more harmful. CFCs, which are refrigerants, I don't know if I spelled that right. Those have global warming potential depending on which one it is. There's a lot of them in the thousands, right? That's why we spend a lot to collect them. If you've ever got your air conditioning done on your car and you have to pay the fee for making sure that they collected that stuff, just hope that they do, because if they did release it, it has a big impact on the atmosphere, right? Or if you have a leaky, this is what all of us, if we have a non-functioning air conditioner, and it's because we lost all of our refrigerant for some reason because there was a leak in the system somewhere, should all feel bad about that, because you just had a big impact on the atmosphere, right? Now, the nice thing is that these two actually don't last that long in the atmosphere. So these actually are interesting because, so if you notice and you listen to this Glasgow discussion, there was a lot of discussion about methane, right? So whereas if we reduce carbon dioxide today, we can't actually reduce damages today, right? So to the extent we're being affected by climate change right now, eliminating carbon dioxide today will not affect those damages. It won't reduce them. However, if we reduce methane, we will reduce it, because methane only lasts for a short period of time in the atmosphere. So methane lasts for only about 10 years in the atmosphere. So right now we've got somewhere between 1 and 1.3 degrees of temperature change as a result of all the additional stuff in the atmosphere. Estimates are if we got rid of all the methane, we'd only have about 0.8 degrees of temperature change, right? So roughly, or I should say methane and nitrous oxide. So getting rid of those actually can give us a benefit that's relatively immediate. So it's a good thing. Maybe it's a good thing that they're looking at methane and nitrous oxide as in addition to carbon dioxide, because actually that's one thing that could actually see some gain from that right away rather than having to wait around. Right. Okay. Just so everyone knows it. So US CO2 emissions, as we've talked about, they have gone down in the electric power industry. They've kind of gone up again in the transportation industry. Through other industries have kind of gone down. stayed about the same in agriculture. The commercial sector, that's basically heating, buildings like, not so much here. I think heating here would actually that'd probably be in this sector, and that's residential, housing, heating, et cetera, right? So the big emission sources in the US are up here, industry, transportation, electric power, like electric power's gone down. Why is electric power gone down? Anyone in this class know why electric power emissions have gone down? Oh, that's a good test question. Why have they gone down? Yeah. Less coal. Less coal. More natural gas and more what? Renewables. What else? Less consumption too. We consume less. Yeah, I'll prove it to you here in a second. So there's Ohio's electricity consumption. So this is just, you guys have seen this 1,000 times, right? Just got rid of the coal, what you just said, added in renewables, kept our nuclear, and increased our natural gas. But this has also just gone down, right? That's the less consumption part. So places like Ohio, which were devastated by the big retraction that started in 2008, and that's really when industry started to decline. It had been declining in places like Ohio and the Midwest for a long time, but really started to speedily decline after 2005, 2006, 2007, after the financial meltdown, and really sort of declining. And it's just less consumption. Stuff. It's a big reason why we've also got less emissions here. And you can put that in numbers for Ohio. Reduced consumption is a big part of why we have less emission change, less emissions today, right? So part of it's just less coal, part of it's the increase in natural gas, part of it's reduced consumption. This was only through 2018. These statistics at EIA always take a little while to get updated. In fact, we don't have the 2019 numbers available yet, so I would provide them, but this will be a little bit bigger, right? The renewables one is kind of catching on now. But the big reason why emissions have fallen in places like Ohio is really reduced consumption, increased natural gas, less coal. We can put that into dollar terms, right? Isn't that great? You guys love dollars? I love dollars. It's all I care about is dollars. So we actually have estimates of what the damages are. And what we can see in Ohio is that the damages from electricity consumption rose for much of the last century and then started to fall starting in 2005. Fell kind of dramatically through 2017. So that's from all the other pollutants. The carbon ones have fallen a little bit less slowly. That's the climate damages. Still started to fall as well. Right. So that's good to see. What can we do with that? What do you want to do with that? Okay, so let's talk about GDP. So GDP is our national income, right? You guys know what the GDP is, gross domestic product. So just an example of how we can use numbers like this, and why it's maybe useful to actually calculate the damages from climate. Oh, I'm sorry. I meant to say that these climate damages are valued with the social cost of carbon, right? That's how we get that value, just so you know, all right? Meant to point that out there. So we're going to use that to augment this GDP estimate, this gross domestic product estimate, right? To say, okay, here's our gross domestic product, but how would we adjust that? How would we adjust that if we were going to try to account for some of these other impacts, some of these environmental impacts? And it turns out it's actually not that complicated. We actually just subtract off the environmental damages once we put them in dollar terms, right? Because GDP is measured in dollar terms. We just subtract off the environmental damages. Simple thing. So there's lots of economic evidence to show that that's what we would actually do. And since we can now actually value these things using the social cost of carbon and using other estimates of the impact of sulfur dioxide, nitrogen oxides, and other kinds of emission sources, we can actually value pretty much anything that comes out of a pipe in the US or any other country to get an adjusted estimate of gross domestic product, right? Yeah.
Do you think that has potential to be adopted on like on a global scale? do you think people would actually, countries would actually adopt that?
Well, so there's two questions there. Is one, would countries adopt it? And yeah, for sure. We do keep track of this now in the US, right? So this is something we keep track of. And there's two different policy objectives, though. One objective is people's income, right? And one objective is balancing people's income with environmental damages. That's a separate objective. So, and different, one of the things is in society is we always sort of push different objectives at different times, right? So during the pandemic, when incomes were down as a result of lots of people losing their jobs, there wasn't an overriding sense that we needed to really be pushing the environmental ones, right? There was much more push on just let's try to increase income. Okay. Hence, we had a Federal Reserve that did what? It really stimulated the economic situation in the US, and then we had a couple of budget bills that went through Congress that tried to increase income in people's hands, right? Without worrying about the environment, actually. Okay, so yeah, we actually already do this and calculate it all, but does it all actually end up influencing every single policy that the government does? No, right? Some policies are just about trying to increase income. Does that make some sense?
Yeah.
Okay, so GDP itself is consumption plus net savings plus government expenditure plus net exports. Is that economics class, if you know that? All right, that's just basically what it is. It's income. What do you spend your income on? You go out and make money. What do you spend on? You consume shit, you consume stuff, right? You save maybe a little bit, maybe you don't. If you don't save, you're borrowing, so that's why it's net savings. If net savings is negative, that means you're borrowing from somebody else. Okay, so that's what you do. That's what the US does too. Government expenditure, that's with your income, some of it goes to taxes, right? And then net exports, I don't know if there's an equivalent for that on an individual basis, but that's there is. Has anybody ever you guys got siblings? You ever just taken something from one of your siblings without telling them? Maybe even tell them, maybe you make an exchange with them, right? Yes, that's kind of like that. You would export or import something from a sibling or your parents. I mean, my kids have gotten really good at taking stuff out of my wallet. They're great at that nowadays, right? So that's kind of like, I mean, it certainly isn't something we negotiate about. So I put negotiation in there. It's more like they just take it. They want it. Did you guys ever get yelled at by your parents? Yeah, I feel like when I yell, it just has the exact opposite effect. In fact, they just start laughing at me, like, yeah, they know I'm not gonna do anything, so funny. Okay. Good. What that has nothing to do with this. All right, so income, those things, environmental damages, what are they? So here's for the utility sector. One more term to add in, value added. I hate throwing a lot of different terms, but value added is GDP. Right? So it's a different definition for gross domestic product. So we're using value added when we refer to specific sectors. If we refer to like the state of Ohio gross domestic product, we call it gross domestic product if it's like the whole state, the whole US. If we refer to like the utility sector, which is the electric sector, natural gas sector, et cetera, then we call it value added. I know economists are just strange. They just have these different terms. So sorry about that, but that's just a term. But so GDP in the utility sector versus the damages caused by the utility sector is kind of interesting. So this is just this is just Ohio, actually. All right. And utility sector in terms of GDP produced was bigger than the damages in the 1990s, but for a period, actually, the damages were bigger than the sector itself, right? And this was the period before the sector had significantly started to reduce the impacts of sulfur dioxide, nitrogen monoxide, and really started to switch from coal and natural gas, right? And ever since then, in the sort of 2005 period, we've seen a reduction in those damages, and the utility sector has gotten bigger. Right? So the adjusted value added to that sector, which is just the difference between these two lines, was positive for a while, negative for a while, and then positive again, right? So, we can calculate these numbers, we do calculate them, present them, and they're, useful for policy purposes. They don't tell us we should get rid of the utility sector. What do they tell us? They tell us during a certain period of time, we did a crappy job of regulating the externalities, right? As a society, we let the externalities get the better of us, and actually, it's not in your economic interest as a society to allow the damages from a sector to be bigger than the economic value of the sector, right? So it turns out we actually got really good at policy and creating a new way forward, and now we've sort of corrected that situation, right? So that's how you would use these numbers. You use them to try to influence policy in a way that you would regulate the sector better, and you would figure out a way to get rid of the most damaging components of the sector. Some of it happened on itself just because natural gas got so cheap, right? But some of it was actually truly just a better way of regulating the sector. This is, I would argue, exactly where China found itself probably about 8 to 10 years ago in terms of economic damages from pollutants in the atmosphere, right? And an effect on, those damages are probably being bigger in some sectors than the contribution of those sectors to economic growth, right? And it spurred big changes in how those sectors were regulated. Same thing, right? Okay, fascinating. And it turns out, actually, if you account for these value-added numbers, and this is the one that include the net value added, the NBA includes the economic damages from climate change as well as other pollutants. It turns out if we incorporate those, because we made such big improvements in environmental regulation, actual growth in the economy was bigger historically than we would have estimated if we just ignored those damages, right? So a lot of what we did, so it's just sort of pointing out is that many of the regulations we actually did impose to try to reduce pollutants in the energy sectors in particular and in other sectors actually worked out pretty well. They created growth in net value added or growth in GDP augmented for those environmental damages that's bigger than growth that was calculated just in income terms, right? So it's a good thing, maybe.
With agriculture in 2002 to 99, and that value add.
Agriculture had an enormous amount of damages in that period. Agriculture as well has become much more efficient over time. It was exceptionally inefficient back in the 80s and 90s. The Farm Bill in 1996 substantially switched the way it was. So the other thing about the agriculture sector, it's heavily subsidized. And it turns out that the subsidies we use in the agricultural sector were incredibly inefficient before 1996. And they drove that sector to be incredibly inefficient itself. So they had inefficient use of most inputs. And it got much better after that. Still heavily subsidized, but the subsidies actually have less of an efficiency burden in the sector.
Also the sulfur dioxide regulations, did those go in like the mid 1990s or was it 2005?
Well, they were actually started in 1990 with the Clean Air Act amendments in 1990, but they put in place the rules in 1994. The actual implementation of the training program didn't start until 2000, and it was mostly a pilot program up to about 2002, and so it was actually full swing from 2002 to 2008.
Okay, that makes sense, because I was looking at the previous graph. And there's a policy like
So
that, not a.
yeah, policy is always like that. It started in 1990 and then it didn't really do anything until. Okay, so, oh yeah, how do we grow jobs in clean energy? Can we do that? So access to a stable energy source. Oh, look at these pictures. Anyone tell me anything in these pictures? Relative to that statement, access to a stable energy source is contributed to economic growth. So it's two countries, US and China. This is energy. The black line is GDP, right? So China's in red, I don't know what's red over there. I did a better job of making the two colors the same. Who you seeing that? Anything? Everything's going up. Is anything going down? Is Newton's law not existing here? What about that? That's going up. That's not going up, right? That's kind of interesting. So it is true. So it is true that access to stable energies has an effect on economic growth, and certainly in the U.S., we've seen that historically. You know, our GDP has risen at the same time that energy has risen, but actually energy is kind of stabilized, right? And income has continued to grow. China may be less so, right? But there's some evidence emerging now that growth in GDP there is less dependent on access to significant amounts of energy, right? So it's interesting that historically it is true that access to stable energy has contributed to economic growth, but that's actually maybe less true going down the road. That maybe is a good thing. Okay, so how does the energy sector, we already looked at this slide, how does the energy sector contribute to economic growth? 3 ways: through prices, as an input into other energy sectors, and as an output itself. So I wanted to just sort of take that slide and convert it to a different question. This is in a different class, so you're gonna have to go back and look at the slide if you're taking notes here. More important question is, how does the green energy sector contribute to economic growth, right? So maybe through prices. So maybe the most exciting thing now is what? The most exciting thing is that, holy cow, technology change has driven down the cost of renewable energy. So, you know, cost of electricity and other energy sources actually should be going down in the future if this trend continues, right? Already has gone down, with energy costs, right? It is true that we're going through higher energy prices right now for lots of things, but that is what? That's unrelated to the technology change, right? Probably a really temporary thing. And we know that this increase in demand, which is causing energy prices to increase sort of across the board, we know that those increases actually would be bigger if we didn't have renewable energy. All right. So the actual counterfactual is still accurate that renewable energy should reduce energy prices in general. Even though energy prices are rising, they're not rising as much because we have a lot more renewable energy out there today than we did a decade ago. Okay, does that make some sense? A little bit. Okay, so one way the green energy sector can contribute to economic growth is through prices, by driving prices down. Helps consumers by doing what? Freeing up money to spend money on other stuff, right? They have to spend less on energy. Helps businesses, so businesses spend less on energy. They can spend more, they can invest more in people, they can invest more in other kinds of productive activities, they can potentially produce more jobs. It is an input into other sectors, right? So green energy is an input into other sectors, and that's really exciting right now, right? But how's that exciting? That's exciting because pretty much every company out there wants to do what? Wants to have green energy, right? So companies are actually making location decisions based on how they can get access to renewable energy. So one reason why companies are moving to Ohio is because we do have a growing renewable energy sector. We're on this PJM grid, so this green energy stuff that we're producing here can be shipped all over the place. So it is a driver of economic growth in a sense that because companies want to have that green energy, they want to be able to say that the products that they produce are produced with electricity that doesn't contain a lot of carbon emissions. You know, they can do it in certain places they can't. And where can't they do it in the US? They can do it in the South. You saw those pictures, right? Well, they can do it in North Carolina. They can do it anywhere else in the South, right? Because no one's putting in renewable energy down there. Right, so it is true that a driver of economic growth could be the demand by companies for renewable energy or energy that has a low carbon content. That's pretty exciting to see. It also could be an output itself, so green energy sector, at least while there's a build out in the green energy sector, it's gonna be a growing sector. Now, it's not, it is true that it won't actually employ as many people as the existing electricity sector. Because it does take less people to, work on a daily basis and solar power installations and wind power installations than it does in large, nuclear power plants or coal-fired power plants. But at least while they're building those things out, and they're building the grid out to at least be able to manage that electricity, that sector will be growing and will contribute to growth, right? So there are lots of ways the green energy sector can contribute to economic growth, right? Yay, whatever. Okay, so just some final things here. What was Glasgow? What was Glasgow? I don't know what it was. Just so you know, I just don't want you to leave this class without knowing all this stuff. You guys seem to know an awful lot of stuff already. I just want to play you guys with more stuff. Seems like your heads need to be filled. You don't have big enough heads. Okay, Glasgow, what was it? The 26th Conference of the Parties called up to the United Nations Framework Against Climate Change. Did you guys know that? You knew that? Really?
I'm taking the climate change class.
Oh, you're taking Brian's class?
Yeah, Brent is teaching it now.
Oh, okay.
Just this year, because Brian is out, but really enlightening class.
Brian's out. Where's Brian? He's seen all his meetings. Good job, too far.
He is temporarily released from his teaching duties, not like, just like he's doing other
I
stuff.
love that.
I know, I'm sure he's
You're like,
really
okay, his
enjoying
house,
it.
they put a NFL strike in front of his house. All right, good. Okay. Well, good. So you got the fiddle player. You play fiddle for you? I haven't played fiddle for you. It's under Grant. It's a good fiddle player.
I'll ask him to do that.
Yeah. Okay, whatever. Okay, so the United Nations Framework Convention on Climate Change. So the UNFCCC, as it's called, was signed and ratified by the US, right? You heard that? So there's actually a treaty. We signed a treaty that says we don't like climate change way back in 1992. And every year after that treaty was signed, there's supposed to be this conference of parties, this meeting of the people who are parties to this thing, the Framework Convention on Climate Change. So they're supposed to get together and just talk about climate change, right? So in one of those things, at the Kyoto one in 1997, they put together this thing called the Kyoto Protocol, which is a treaty that was ratified by lots of countries, not the US, and did some things, but really not a lot. The Paris Agreement, which you hear a lot about, was actually discussed at the 21st Conference of Parties. Where was that? Where was that Conference of Parties? Anyone know where the Paris Agreement was? Was it Toledo? Yeah, it's in Toledo. You guys should actually do that. You should actually recommend that they have a Conference of Parties in Toledo. That'd be great. All right. Okay, so there will be another one next year. I don't know where it is next year. But the Glasgow one was, just another one. One every year. I would say you should go to one, but they become such a big mess that, I don't know that you should. Besides which, they're never in the US. Why are they never in the US? Because no one likes the US. No, it's because the UN is in the US, so they don't want to hold it in the US. Typically in other places. Okay, so why was there so much emphasis on net zero? Why net zero?
We can't get to gross zero.
What was that?
I said we can get to gross zero, so we might as well get to net zero.
Okay, yeah. So one thing is what is net zero? So these are different pictures of future emission pathways, potential pathways that involve emissions and then sucking of carbon out of the atmosphere, okay? Using trees and other kinds of biological material to do it, right? So anything on the bottom here is sucking stuff out of the atmosphere, right? Anything on the top is emissions. And this thing, the line is like the net between the two, all right? So net zero is the point where that line crosses zero. So it's the point where our sucking of stuff out of the atmosphere equals our sticking of stuff into the atmosphere, right? Is that relatively okay? All right. So that's what net zero is, right? And basically, the reason why we focus on that by 2050 is why. So you have to go all the way back to that picture. Remember I showed that picture earlier on? Said, remember this picture? Well, there's estimates out there that say that, you know, if we want to avoid temperature changes above 1.5 to 2 degrees, there's only so much more carbon dioxide to put in the atmosphere, right? So based on what most people expect to be emission amounts, right? The estimates are that we really have to get to net zero by 2050 to keep from filling that bathtub up even more than that would drive us above 1.5 to 2 degrees, right? Does that make sense? So there's a limited amount of stuff we can still put up there in terms of carbon. And basically the calculations are somewhere between 2040 and 2060, we have to be at net zero in order to avoid putting too much up there, right? So that we go above that 1.5 to 2 degrees. These pictures just show there's lots of ways to do it. One way is to stop emissions growth and start dramatically reducing emissions like right away. Other ways to do it are to overshoot, to keep emitting at increasing rates for a while, and then dramatically reduce the emissions, but at the same time, suck carbon out of the air through what's called DECs. So we basically plant annual crops, chop them up and burn them for electricity, plant trees, chop them up and burn them for electricity, et cetera, et cetera. So we use photosynthesis to produce electricity, and then we take the carbon from the burning of that electricity, burning of that biomass for electricity, and we take that carbon and stick it on the ground somewhere, right? That's what DEX is. So it's a way to just suck stuff out of the, suck carbon out of the air, right? Okay, so you know, we're not sure which pathway is the best, but we do. So the one thing we know is that if we really want to get to net zero by 2050, we have to use these land-based options. We have to suck carbon out of the atmosphere somehow. I mean, because otherwise we have to start like yesterday, right? I mean, remember, our emissions are still going up, right? They're not going down, they're still going up. So, I mean, we'd have to get to net zero without any of this stuff on the bottom side by 2050 or anywhere before that, we really have to start reducing stuff like that. Okay, so that's what Glasgow was about, was this whole discussion about, you know, could we get ourselves on a pathway for that? Maybe they have. This is just a picture to show you that we can use potential carbon credits for that. Ever heard of carbon credits? Exciting stuff. Exciting brand new world. This is where I bet half of you have jobs in this space in the next decade. Really exciting stuff. I mean, this is really fascinating. These people who can do this are going to make millions, and there's lots of people interested in it. So what are carbon credits? So right now we're sucking stuff out of the ground, right? We're burning it, putting it in the atmosphere, get out of the ground, right? That's what this class is all about. But photosynthesis sucks that same carbon dioxide out of the air, sticks it in plant material, right? Or sticks it underground in soils. So by doing conservation tillage, cover crops, some of these practices that people suggest are really good for farmers to do, they also suck carbon out of the air and put it in the soils and get stored there, right? So that's a good thing. So we can actually create marketable commodities out of that, right? Because it's worth a shitload. I'm sorry, I'm going to use that word. These companies will pay a shitload for that. Why? Because they're getting pressure from their consumers to become net zero by 2050, right? So all those 30,000 people who went to Glasgow, plus all of you and me and everyone else who wants our companies to be better stewards, right, are saying, well, become net zero. And the company are saying, well, I'm still using oil, still using coal, still using natural gas, so I'm still going to emit this stuff. The only way to become net zero is to do more of this stuff, right? So there's a massive emerging market in figuring out a way to take all the money that these companies are generating, producing products we all want, right? And products we all want to be green and are willing to pay for. So they're willing to spend a lot of money to get more of this stuff done. So there's like an amazing, massively emerging market in building up and supplying credits that are realistic, that actually produce avoided carbon in the atmosphere and selling them off to companies, right? This is not just this. I mean, these companies have all made these commitments. This is just some of them. These are the ones that are active in Ohio, but they've made significant commitments. Now, they're just commitments. I mean, they're not like they've actually been regulated to do this, right? Glasgow does not regulate anybody to do this. The Biden administration has not yet regulated any company to do this, but consumers are regulating these companies, right? They're telling them they wanted to do this. These companies are trying to figure out ways to do it. Pretty phenomenal. Here's carbon prices. They were really going down. So this is from 2008 to the present. This is carbon prices for these offsets, right? This is carbon prices, the willingness to pay of people for 1 ton of storage in trees or carbon in soils or peatland. You ever heard of peatland? You know what peatlands are? You know, peat soils. Well, you know what peat are. Anyone drink scotch? Right? Yeah, so it turns out that these peat soils exist all over the world, just like they do in Scotland. And it's amazing. They're just massive storage. They're basically pre-coal or pre-natural gas before it gets buried by some future geological event. So, but they store a massive amount of carbon. And in places like Indonesia, Africa, some of Latin America, many of them are getting cut into, the trees are getting cut down, they're getting turned into agricultural land, and that releases a lot of that carbon actually, right? So, and some of them get used for the energy. Protecting those is really valuable, and it has a carbon price associated with it. So, you know, these carbon prices have started to come back up. This was as of August. They're actually significantly higher now. They're more than $14, $15 a ton. So these credits have become really valuable. The idea that you could actually figure out a way to supply these big companies with these carbon credits is a brand new sort of market that's huge. It's like 600 billion, 0.6 billion tons or 600 million tons per year. It's about I don't know. People think the current market could reach 90 to 120 million tons or 2 billion per year. So it's going to be a big industry, right? And simply to try to become net zero. All right. So this is just encouraging you guys to get into this sector. It's growing, it's big, it's huge. You're gonna love it. And you can do it out in the woods. You don't have to be hanging out in a classroom. You can go outside and do it, right? Create these carbon credits. Isn't that exciting? That's all I got for you today. All right. Now Thursday it'll be even better. And then next week it's even better. Why is that? And for class next week, but you are working on your project. So get your project done this week. Work on it next week. No class next Tuesday. Next week. Next week.
Yeah.
Okay, we're taking that off to work on your project. That work for you?
Yes.
Yeah.
Are you just